Alright, let's look at the theorem 1, angle side angle theorem. Alright, so if we have angle side angle, so for example, angle A is congruent to angle X, and segment AB is congruent to segment XY, and angle B is congruent to angle Y, then this will imply that triangle ABC is congruent to triangle XYZ. Right, so let's do that. So we have a congruence between angle A and angle X, and then congruence between segment AB and XY. Right, then angle B and angle Y. Right. So those are the givens. Alright, so let's do all cases. All possible cases would be either triangle ABC is not congruent to triangle XY, XYZ. Right, so I have to put XYZ. Right, or they are congruent. So triangle ABC is congruent to triangle XYZ. Right? So those are the all possible cases. I'll just say all cases. Alright, so let's pick on the first case, 5. Alright, so let's assume that triangle ABC is not congruent to triangle XYZ. Right? So this is our case 1. And if we can eliminate that, then we'll set, because we can establish the congruence between those two triangles. Alright, so let's do that. So since we already have side angle here, so side angle, so if we know that these are not congruent, then segment BC cannot be congruent segment YZ. So we know that here, with this assumption, we know that segment BC is not congruent to segment YZ. Right? So this comes from line number 5 and also C1. So I would just say C1 because otherwise it's going to satisfy side angle side. Right? So we know this. Right? Then I'm going to actually make our lives a little bit easier by assuming, making this extra assumption. We may assume right, since these two BC and the segment YZ are not congruent, so they are different lengths, which means that the one is longer than the other one. So we just assume that the BC is the longer one. So BC is longer than YZ, right? If the other way around, the argument is still be the same. Right, so we just say without loss of generality, we can make this extra assumption. Right, so we are saying that here base BC is a little bit longer than YZ. Right, so what can we do? Then we know that let's see, 8. Right. Why don't we construct a point, let's see, somewhere here, D, so that this length is going to be same as YZ. Right? So we know that there exists some point D between B and C, so open segment BC, such that measure of BD, so BD is going to be congruent to segment YZ, right? This is by segment construction theorem. Right? Remember that when you have a longer segment and a shorter segment, we can cut down the longer segment to match the shorter segment. So we have that. All right. Then we can just draw a segment AD here. All right. Then we notice that since we have, if you look at the triangle ABD and XYZ, we have side, angle, side. So we know that we have a congruent triangle. So we know that the triangle ABD is congruent. Oh, D I meant. Congruent to triangle XYZ. Right. So we're saying that the triangle here is congruent to triangle XYZ, right? So this is by side, angle, side, right? So side, we know that here, line number 2, right? Angle is line number 3, so those are congruent. Then BD is congruent to YZ, so this is come from line number 8. Alright, so we have that. And line 10. Alright, so if they are congruent, then we know that the angle, oh, not triangle, angle, BAD is congruent to triangle X, right? Because BAD corresponds to X. So the justification would be corresponding. This is a typical notation. Corresponding parts of congruent figures. So CPCF stands for corresponding parts of congruent figures. Alright, so we have that. Alright, then we get in trouble because if you look at the measure of the, say, angle A, which is going to be BAC, and I'm going to use measure of angle A, which is the sum of the measure of the angle BAD and the measure of the angle DAC. Right? Then, so since there's no zero measure for the angle, so we know that this is definitely larger than measure of the angle BAD. Alright, then let's make sure, let's look at the axiom here. Alright, so if you look at the angle axiom, A1 says that here, angle measure is always strictly between 0 and 180. Cannot be 0, cannot be 180. So we know that it's always positive. Alright, alright, so since this guy right here, this angle is always positive, so therefore, if you take that away, so angle measure of the angle BAD is going to be strictly smaller than this. All right. Then we have, let's see. So we can actually. All right. So we are using the fact that here A1 and also A2. All right. So justification is it's A1 and A2. Right? Then by combining those two guys, number 12, alright, so we know that the angle, measure of the angle A is strictly larger than measure of the angle BAD, but the measure of the angle BAD is the same as the measure of angle X. So therefore, measure of the angle A is actually strictly larger than measure of the angle X, which contradicts line number 1. Right? So this is just coming from combining line 10 and line 11. Right? So this is a contradiction, so therefore the first case is eliminated. So this guy is eliminated. So therefore, line number 13, triangle ABC must be congruent to triangle XYZ, which is by rule of elimination. Right? So this was case 2. Right? Alright, so that's it. So we could establish establish a congruence between two triangles from angle, side, angle by assuming side, angle, side. So side, angle, side actually help you establish the angle, side, angle theorem. Alright, that's it. I hope that this was clear.